Hello everyone, I'm Xiao Gang. So after we demonstrate it to you, you might think it's quite troublesome. So does Unreal provide us with some powerful support and help, allowing us to do such work more conveniently? Of course, Unreal does provide that. Then here we introduce two new modules, which are GL and GIs on YouTube. Next, we will use this UE method to complete this JSON. Okay, so these two tools, we go back to our JSON actor again. Then we will show you again. We call it good JSON. This is a good way to write data. Let's start with the simplest one. Then we need to use this struct. Moved it outside. Yes, we might still need to use this temporary struct. We move it outside. This version is the simpler one. Then we put this here. So we still write the saving, but the way we write it is quite different. We ensure it compiles here. Good, it compiles here. Then we go back here. Then we need to include this header file. Okay, we mainly include these header files here. I include them all at once because we'll need them later. We don't need to add that many. As for these header files, it is actually a JSON reader, writer, and a JSON converter. This is the JSON reader, writer, a template that will be used, and this is for writing. Is it for reading? And this is our second method, which is to directly reflect the blueprint and convert it into UEG and information. Then let's take a look here. How to write this code? First of all, we need to prepare a string. Yes, we prepare a good string for it. Good string. It is an empty child. Right, then through this code, we create a write stream for it. This is a fixed pattern. This is the code. You can directly copy it over. Then pay attention to the indentation here. Pay attention to this template parameter. It may control the output. This template may has some indentation control here. Then some backends. Some backends may or may not have indentation. Some backends may receive data. It might be due to network transmission. With or without spaces, these situations can occur, and then it will cause the instructor to not pass the review. If you encounter this issue, you need to investigate it. Of course, I have encountered this before, but when I encountered it, some service providers can work without it. After you write it, it will automatically check within its code whether there are spaces. Say all of this, it does not affect its control over this result, but some service providers are very sensitive to this. For example, in this interface, if you press enter one more time, if you add one more space here, it might not be able to recognize it. There's not much you can say about this because this is a backend issue. It has nothing to do with us on the front end. We just know when there is such a problem during linking, if everyone needs to analyze the problem, this is enough. And then, so we need to write this object. First, we call it GodKiss. Let's change the name. GodKiss Writer. Then we can start writing. When it comes to writing, that is to say, we can WriteObjectStart. Its meaning is actually quite simple. You see, WriteObjectStart. It essentially means to add this curly brace. You can simply understand it as just add it as a curly brace. Then after you add the curly brace, you will definitely need and then you need to put this bracket in. That is, you need a closing brace. So you need to put the closing brace in. Okay. Then next, since you want to open this stream, then you need to close this stream. Only then will it work. Otherwise, there will be problems. So this actually means there is an empty string. That's what it means. Then we gradually add properties into it. For example, let's write the first property. It is a lambda, an int. So we can write value like this. And here, we actually write a code. Then we copy this property over. We put this here. Here we can directly copy this property over. And it is actually a generic method. You see, it is generic. So the generic here means it can automatically identify these types for you. You don't need to write %d here, succession, or anything like that, because it will automatically recognize it for you. Then after writing this code, let's write these 3 strings. We can do it this way, okay? Then at this point, let's copy these later parts. Our S, it should be message. Then data. Then let's copy these over here as well. Okay? After copying them over like this string logic is actually already written. At this point, we still use the same method. We serialize it to this local location. Let's serialize it first. Finally, let's work on serialization. We call it the good base layer. As for this path, we are using this base layer. Okay, let's first show you the serialization. Let's show you the serialization first. This way it will be clearer for everyone, because I'm afraid if I go too fast here, it won't be good if you can't absorb it. Okay, we are already in here. You can see we have a struct here, right? Now let's take the struct and wrap it in, and here it is empty. See, after writing it, it's still empty. But actually, because this place is still empty, it's because we haven't written the real content into it yet. This place is just alive, such an object. You see, then we close it. You can see that it has entered now. It looks like this. You can see, yes. So this proves that our writing here is fine. Then we write it to the local. In the local area, let's check it in the local area. We can see this good JSON. Then we party it up a bit. Hey, someone found these and was satisfied. Then we continue to refine our JSON. There's an info here, right? So let's take a look. If we add an info, how should we write it? So I'll just steal it from here. Here we put it over. So we write it like this. We'll put it here instead. Everyone should be able to absorb this knowledge. Okay, good. This struct here corresponds to this struct, and this one is not needed. Okay, we move it over like this. Okay, so we need a data structure for info, which is actually called servolam and servovision. Then we'll modify it here. Okay, let's add another one here. So we want to declare this struct above. This struct contains 2 strings. To distinguish them, we're afraid the names might confuse you. You can absolutely write them the same. That's completely fine. Okay. Then how are we going to do it? After we finish this part, we instantiate a struct here. Let's call it user_var_info. Okay. Then, with that done, we can assign a negative value here. So the first value is serverlam. We gave it txt dash. And then here UE5 stringinfo, just wordation. Equals 19,356. Okay, with this in place, we continue to add things here. Actually here, you can freeze a distinction because you need to write the second object. Then you directly write. Oh no, so here you need to add a name. You need to pass a parameter like this. This way it will do some corresponding work for you. And here you need to finish writing it. Right, and here write a name for lesson volley. It is actually seroname and seroinfo. And here it uses these two properties. Okay, alright, and actually at this point we need a pair of curly braces to make it easier for you to read. Because if you don't write curly braces like this, you will actually have trouble reading it, since it is actually separated into a layer like this. You see, it should be like this, and we can do it like this, like this. Okay, right, yeah, right. And now let's execute it for everyone again. Okay, and now we execute and see. Press 1. It seems there is no breakpoint here. It didn't break here either. Let me restart it here. Actually, we don't need to break here, because it seems like it brings the close back up. Virtualize it in. Let's directly take a look at our stubborn hierarchy. Let's open it. Take a look at this stubborn hierarchy. It hasn't been changed yet, right? We need to execute. Press 1. Let's check again. Okay, we have already executed it for everyone. Executed. You see, let's directly look at this segment of ours. Then here you can see it seems like this part has passed. Let's press it again. Press it again. Okay, let's go in. Then here we start to create the struct information. So here, our saving, after we finish it here, it actually already meets our requirements. Then we save it locally. Then after we go over there, we go to this place to check our stubborn wiring. And sometimes this one might not have been refreshed. It just hasn't been refreshed. This is very normal. You can see, let's xt it. Okay, so at this point, this connection is the format we want. This is a tree node nested inside an object. Of course, you can continue nesting. And now let's continue writing this handler. Continue writing this handler. Let's close it first. Then go back to our handler. Let me check what information we haven't written in yet. Okay, then we imagine there is a host here. And also this, we call this a host wrapper object or something like that. Let's write the host first. Let's write it all together here. Close it. As for this number, we probably need to write it here. Let's find it. The name of this number is worker IT. It is app TTN. We can use indate. Using int free2 is also fine. Let's finish writing it together. And then this method is a coder. The coder is lambda, and we'll write it here. Let's call it work. Temp worker info. Then the names are lam and worker year. For this year, we can use negative point values. Actually, it doesn't matter over there. Okay. Let's use negative point values. Using negative point values is good for demonstration. Then 1.3, 3.2. Then for this we use negative point float and set it equal to -1. Okay, then here we need the tearaway struct. This struct is called coda info. Yes, and its name is lamb. I can keep it simple. It doesn't need to correspond here, but you can also map it. Here we have some mappings for you. Some are not mapped, but we usually recommend that you do this mapping because when you write code like this, it will be easier for others to read. This is just for distinction, so we didn't set up this mapping for you. And here we can add this. This should be our worker ID. Then we directly add. We add 135. Just write something random. Okay, so we need to match this 125. Then next we go ahead and add our coder. Then we add it like this. We write and add default. Get reference. Then we add default, add default, add a default one. We check if it has a return. It returns a size type. Then we do it this way. Net code. Nest. This is the support for our array. We set its first name equal to xg. For the connection, let's write it again. For the first connection, we give it a 3.2. Similarly, we execute it again. Execute it again. Here, we give it a GCC. Give GDX a 1.2. Okay, next, we will write our array here. And similarly, this is an array, right? So this kind of data. We let it. What? And here, of course, you need to make it a parameter because it is something inside. So you need to pass in the name of this array. Its name is obviously called this. Cold work it. This name inside the generation. We put it outside. Put it outside like this. This looks a bit better. So it's still placed inside, but have a beginning and an end. We placed it inside. Put it here. Okay, actually you can click to see it's actually this thing. Quite simple. And then with this host, we can write. Write. Okay, that's it. So here, we'll just make a negative loop. We loop this. Originally, our workers. Then our side can directly use this. Through this way too. First get the ID, then through it we write this value. Right. Then this values. Writing this value, let me think, should be able to write directly into it. Okay, let's just write directly into it. Okay, it should be fine. Directly write this element in the number. Then write it like this. Finished writing this element. Then the one after this is quite special. It is also WriteObjectStart. Then this part is this coder. Then here we also need to iterate, right? We also need to iterate. Then here, where there is a start, there must be an end. Then what we iterate over is this element, the coder element. It is a struct. Then here we need to loop through this object star. Okay, then note this object star. We won't pass parameters. Then this, because it looks like this. You see, it looks like this. We need to write a curly brace. Write a curly brace, and this one doesn't have a colon before it. That is to say it. You see, there is an info with a colon before it here. It doesn't have one before it. So we directly write a curly brace. Let us have parameters. And this host is called parameters here. And then here, actually, it's just two pieces of information. Let's call This information, these two pieces of information are respectively name and whopper. Okay, then let's call this field in. So it should be quite obvious that this field is like this. This field is this lamb here, the lamb in timecode into, and the worker in this timecoder. Okay, so we're done writing this. Let's debug it here. Okay, after we step into the debug here, because it's written in the buffer, we might not be able to see it all. We need to let it finish executing to see it. Because we can see this JSON, here you can see it writes a lot of things. Look, let's not touch it, let it finish executing. Look, here it is, writing this object. Finally, write this host object. Done writing, close. Now let's take a look at it. Let's take a look. See if this meets our standard. Let's let it finish executing. Let's look at it in BS. Okay, if we can't see it here, let's close it. Because it changed. Maybe it didn't detect the change. Let's go back here. Go back to our save. Find this good JSON. Hey, look, now we party it, proving there's no problem. After writing this, does it correspond to our message? Okay, so we have finished explaining this part. Alright, let's read this level in the next class. Yes, we can't continue to the next part. Yes, we need to serialize and deserialize this level now. Okay.